Hi there. Okay, so I realized that when we do Pythagorean theorem, this is video notes unit 5, number 2, by the way. When we do Pythagorean theorem, there's often times where we get to radicals and we don't know how to simplify radicals. So the objective of this video is just to review what radicals are and how to simplify them algebraically. And these are numeracy skills, and this is expected that you know how to do these numeracy skills when you get to our class. So I'm going to use the word radical and simplify and rationalize the denominator. So the big thing is about radicals. If you take the square root of a square, so this to undo, you have something squared. That's how you spell squared. And then to undo it, you take the square root. Okay, so this is the opposite. To undo a square, you take the square root. To undo a square root, you square it, type of thing. So what happens is if you have something that is a perfect square on the inside, that, I'll rewrite it like this, something squared on the inside, you get that something back. So as long as you have something squared, you can remove the radical, and then you can leave whatever is squared left. So for example, in this case, we have 17 quantities squared. So to 17. So to undo the square root, to remove a number out of the square root, it has to be something squared. So your answer would just be 17. So I'm hoping that this looks familiar. Let's actually just like run through some more examples. So that was the first example. Example number 2, you have, if you can get it to look like this, something squared, then whatever is in here will just end up being your answer without the square root. Then it's released from the square root if you can get something squared. So the square root, so if we did 2x to the second power, because if you square this, 2x to the second power, you get 4x to the fourth. So whatever is on the inside here, that can be released from the radical as well. Another way to think of it is, I think what's more commonly shown is you guys see this. So there's 2 of these, so you circle it and bring it outside the radical. You're left with 2x squared, the square root of 1, and that just goes to 1. So you might be more familiar with this, where you write it out multiple times and take it out of the radical. That's fine too. Okay, let's go through another example. Okay, this is example 3. So we have the square root of 72. This is where you can break it up into perfect squares. Remember your perfect squares, you know, they're like 1 and 4 and 9 and 16 and 25 and 36 and x squared. These are all perfect squares, which means if you take the square root of them, it's going to be a whole number. So 72, I like to break it up into factors. So I think of 72 as 9 and 8 originally. And then you can just break it up even more. I know it's 36 times 2. That's another way you can break it up, 36 times 2. That way this is a perfect square. Take it out. But I don't always think of 36 as my first, this is a 6. I don't always think of 36 as my first factor. So what if I broke up this 9 and 8 all the way? 9 and, 2 times 2 times 2. So what if I did the prime factorization of 72? 3 times 3 times 2 times 2 times 2. Then, a 3 can be released. Then you're left with 2 times 2 times 2. And 2, because it is a square root, not like a cube root or fourth root, 2 can also be released. The reason why I'm writing it like this is because even though, yes, I know it's 6, I want to show you that it is multiplied together, because soon it's not just going to be numbers, it's going to be letters and variables in here too. So yes, you can multiply them. You do not add them, you multiply them. Alrighty, let's do another example. I think we're on example 4. So example 4, yes, example 4. This one, I say yes, because this one is actually going to come up a lot when we do our trigonometry stuff. So you're going to get the square root of 1/3. Say, for example, do I want to do this? No, okay. So if you have the square root of 1/3, you have a fraction here. So this is a fraction situation. So this can actually be broken up into 1, square root of 1, and the square root of 3, which is like, it helps us a little bit because we get to this part. Now, you have to do something called rationalize the denominator. Rationalize the denominator. Here's one of your vocabulary words. I feel like I've done this video before, but for algebra 2. Same concept. So rationalizing the denominator means that we don't want a radical in the bottom. So what we do is we multiply by a property of 1. So whatever we do to the bottom, we have to do to the top. This should look familiar. So when we rationalize the denominator, you have the square root of 3 in the numerator, and the square root of 3 times the square root of 3 is just 3. Okay, so if you get this, the appropriate way to rewrite it for your final answer looks like this. This is just convention. This makes me understand you know the concept, but let's practice your numeracy and algebra chops so that if you see this on a selected response question, it'll show up like this. Okay, let's do another one. Okay, let's apply this scenario here. So we're actually going to use our skills of Pythagorean theorem and rationalize the denominators. We're going to have square roots in these cases, and it's okay. So first of all, determine the shaded area of the region below. All I see is 2 circles with a radius. This is a radius. This is also a radius. This is a radius, and this is a radius. They look like they're congruent circles, so everyone should have the same radius. Okay, so if I were to draw out this triangle like this is a 90-degree triangle. If this is R and this is R, I put radius. They're the same length. The radius is the same distance at any point on the circumference of a circle. That's the definition of a circle. So let's use Pythagorean theorem to solve this part here. So if we have a squared plus b squared is equal to c squared. Remember, the hypotenuse is opposite the 90-degree angle, and it is the longest side here. So we have r squared plus r squared is equal to 10 squared. So we have 2r squared. We're doing all this to solve for r. If we solve for r, we might be able to find some more information about this. Okay, 2r squared is equal to 100. And check out this algebra skills. To isolate r, you divide both sides by 2. You get r squared is equal to 50. R is equal to the square root of 50 or the negative square root of 50. But because we're dealing with distances, we're going to throw out the extraneous solutions of negative numbers. And I see 25 times 2. So this come out as a 5 root 2. All right, so our r value is 5 root 2. I wonder how that helps us. Our r value is 5 root 2. I should sit up. Okay, how does that help anything? Well, it gives us some information. So if I can find the area of this rectangle and subtract away a quarter, I don't even know what colors these are, subtract away quarters of circles, then I can find the shaded area. So let's find the entire box here. Box is equal to, this is also 5 root 2. This distance here is 2 times 5 root 2, which is 10 root 2. If you don't know where this 10 root 2 comes from, put a little star or put a little caution sign so you figure out where that 5 root 2 comes from. I mean, that 10 root 2 comes from. Okay, so the area of the box is 10 root 2 length times the width, 5 root 2. So this is 50 times 2. Root 2 times root 2 is 2. Okay, now we have to subtract away the quarter circles. Quarter circle. What some of you know and some of you don't know is that the area of a circle has a formula. Some of you have not done this. So if you know somebody that has never done area of a circle, can you help them out, please? Okay. So the area of a circle is this, pi r squared. Remember Pi Day? Everyone loved celebrating Pi Day. Yeah, this is the real version of it, okay? If we divide by 4, it's because each of these orange sections, there's 2 orange sections, is just a quarter of a circle. All right, so we know what our radius is. Our radius is 5 root 2 squared over 4. So this is how you do squares. You have to square both the 5 and the root 2. So 25 times 2. Remember, Root 2 squared is just 2. It's not 4. It's the square root of 4. So 2 divided by 4. All right, so now we're left with 50 pi over 4, which is, if we're simplifying it, 25 pi over 2. So this is for each quarter of a circle. Each quarter of a circle is 25 pi over 2. Yeah, I'm going to leave it like that. Yeah, that's a great number. No, I'm not going to put decimals. 25 pi over 2, 25 pi over 2. Woo! So we have the areas of the circles. We have the total area, which is highlighted in yellow, which is the box. So the area shaded is shaded area. Oh boy. Oh, I did something. The shaded area is the whole box minus one of those orange circles, one of those orange quarter circles, minus another one of those quarter circles here, which if you are feeling real fancy, this would equal to negative 25 pi. And then you would just leave it like this, 100 minus 25 pi. All right, now summarize the biggest things. What did you not know how to do? What did you get stuck on? Because you're going to ask your teacher about that the next day. And then what else do you need to know? Look back at the objectives. Can you fluently simplify radicals in simplest form? Can you add them? Can you multiply them? Can you rationalize the denominator? And can you use them in Pythagorean theorem? Okay, that's this video. You might have to do another video. I'm not sure. Bye.